All right, let's talk about cooking, but not about recipes. Today, we're going behind the scenes, into the actual science of what makes food taste so good. We're going to break down the fundamentals, and I promise it's going to completely change how you look at every single meal you make. I mean, really think about it. You drop a steak into a hot pan, you hear that sizzle, you see it brown, it totally transforms. But what's actually happening in there? Well, it's not magic, it's this incredible dance of chemistry and physics, and we're about to learn all the steps. Because at its absolute heart, that's all cooking is. It's just applying energy. Every single method, whether you're using a campfire or a fancy induction cooktop, is just a different way of getting energy into food. And it's that energy that turns raw stuff into an amazing experience. So here's our game plan for today. We're going to start with that sizzle by harnessing dry heat. Then we'll get into mastering moist heat. After that, we'll look at some surprising ways to cook without any flame at all, and then we'll pull it all together into a blueprint you can use in your own kitchen. Okay, let's kick things off with that amazing sizzle. That sound is born from dry heat. This is the world of crispy skin, savory crusts, and all those deep, complex flavors that we absolutely crave when we're grilling, roasting, or frying. The key difference here is what's carrying the heat. We're not using water. Instead, that energy is moving through superheated air in your oven or hot fat in a pan. And that intensity, well, that's what unlocks some of the most delicious chemical reactions in the kitchen. You know, that sizzle isn't just the sound of water evaporating. No, that's the sound of flavor being created. It's called the Maillard reaction. It's this wild chain reaction between amino acids and sugars that creates hundreds of new flavor compounds. It is literally the brown in golden brown and delicious. But for that magic to really kick in, you need some serious heat. The Maillard reaction doesn't even get started until the surface of your food hits about 300 degrees Fahrenheit. This temperature is absolutely crucial, and it's exactly why you can't brown food by boiling it. Water's boiling point is just way too low. And here's the cool part. You're already an expert at this, even if you didn't know the science behind it. Every time you roast a chicken, grill a burger, or even bake a loaf of bread, you're using the exact same principle. You're using dry heat to get that perfect browning and build incredible flavor. Just think about roasting. Your oven creates this hot, dry environment. That circulating air pulls moisture away from the surface of, say, a pork roast, which lets the surface get hot enough for that Maillard reaction to do its thing, and boom, you get that irresistible crust. But hey, browning isn't everything. If you think about dry heat as creating flavor on the outside of food, then moist heat is all about transforming the inside. It's the secret weapon for making tough foods unbelievably tender and juicy. See, the two methods have totally different goals. Dry heat uses that intense, high energy to get you crispness and browning. Moist heat, on the other hand, uses the gentle, penetrating energy of water or steam to tenderize food and infuse it with moisture. Different tools for completely different jobs. And the techniques here are a lot gentler. You've got boiling, which is the most aggressive of the bunch, then delicate poaching and steaming, and then you have braising, which is the absolute superstar of the moist heat world because of its power to transform. The superpower of braising is transformation. It's specifically designed to take those tough cuts of meat, the ones full of connective tissue, and over a few slow hours, it melts all that collagen down into rich, luscious gelatin. That's something that intense, dry heat just can't do. And here is where it gets really brilliant. The absolute best braises actually use both methods. You start by searing the meat. That's your dry heat step, building all that Maillard flavor. Then you add liquid, cover it up, and let the gentle, moist heat work its magic for hours. You get the best of both worlds. Okay, so we've got dry heat and moist heat down, but what if I told you that you can cook food without any heat at all? Let's dive into the world of chemical transformation, because it's pretty wild. This kind of reframes our whole idea of cooking, doesn't it? Because while heat is definitely the main event, a huge amount of food transformation happens in other ways. We're talking about pure chemical reactions, using things like salt or acid, or even just mechanical force to change food's texture and flavor. Just think about it for a second. Curing with salt is what fundamentally turns pork into bacon. Pickling with acid is what cooks a cucumber and turns it into a pickle. Fermenting uses tiny microbes to create the incredible flavor of sourdough. All of these are types of cooking, total transformation, without a single flame. So, what does all this science actually mean for you in your kitchen on a Tuesday night? It means we can stop just blindly following recipes and start using a powerful framework. This is your culinary blueprint. And this right here is the single most important takeaway. Great cooking isn't about memorizing 1,000 recipes. It's about understanding your ingredients. When you look at a tough chuck roast or a delicate piece of fish or a waxy potato, you'll now know how to choose the perfect method to make it shine. This chart says it all, really. If you take that tough cut of beef and try to roast it with dry heat, you're going to end up with shoe leather. But if you apply the correct method, a low, slow braise with moist heat, it becomes fall-apart tender. It's the same ingredient. The only difference is choosing the right kind of energy. So let's just recap the big ideas. At the end of the day, cooking is just energy transfer. You use dry heat when you want flavor and browning. You use moist heat when you want tenderness. And the master rule that ties it all together: understand your ingredient first and then choose your method. When you understand these core principles, you're not just following a recipe anymore. You're conducting an orchestra of flavor and texture. You know the science, you have the blueprint. So the only real question left is, what delicious experiment are you going to run first?